Swayam Prabha. Digital India. Educated India.
Now we have to revisit the unconstrained n-dimensional optimization technique, and some more problem also we have to discuss, and let us go with the steepest descent method or Cauchy method. The algorithm says that start with an arbitrary initial value x1, set the number I equal to 1, find the search direction Si as Si equal to minus delta Fi equal to minus delta into f of xy, and determine the optimal steps length lambda I star in the direction, and set x suffix I plus 1 equal to xi plus lambda I star into Si, which is equal to lambda I minus lambda I star into del Fi. Test the new point x suffix I plus 1 for optimality. If I plus 1 is optimum, stop the process, otherwise go to step 5. Set the new iteration number I equal to I plus 1 and go to step 2. For example, you take a minimum of f of x1 comma x2 equal to x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square, starting the point x1 equal to 0 0. First iteration, the gradient of f is given by del f equal to dou f by dou x1, dou f by dou x2 of the matrix operator, and f you know partially with respect to x1. So, it happens x1 partially with respect to 1 is this is 1, and then what happened x1 partially with respect to x1 is 1, and then x2 is 0, and 2x1 square differentiate 4x1, and 2x1 x2 partially with respect to x1 is 2x2, x2 is 0. And similarly go to the same equation 1 partially with respect to x2, we have minus 1 plus 2x1 plus 2x2. Now we have a matrix of del f equal to del f1, which is equal to del of f of x1, means x1 and x2 equal to 0, this is given here and substitute here. So we have 1 comma minus 1. Now we have S1 is del f1, that is 1 comma minus 1. So this value you have to denote S1 with the negative sign. Now we find x2. So our aim is to find the optimal step length of minimum of f of x1 plus lambda 1 s1, and x2 equal to x1 plus lambda 1 s1, and x1 is what is x1? 0, x2 0, therefore this is 0 0, and lambda 1 we do not know, keep as it is. S1, this is S1, and then we have substitute S1 equal to minus 1 1, add the matrix minus lambda 1 will come. Therefore, f of x1 plus lambda 1 s1 equal to f of minus lambda 1 comma lambda 1, and substitute in 1. So, 1 is this given function, this is 1. Therefore, we have minus lambda 1 plus 2 lambda 1 square minus 2 lambda 1 square plus lambda 1 square. So, cancel these two, and then minus lambda 1 minus lambda 1 minus 2 lambda 1, and this is lambda 1 square, and differentiate the above, this is f, differentiate above with respect to lambda 1, therefore it become minus 2, it become 2 lambda 1. So 2 lambda 1 equal to 2, therefore lambda 1 equal to 1, and x2 equal to what? 0 0 plus lambda 1 is what? 1, lambda 1 is 1 here, and S1 equal to minus 1 1. Add them, we have the matrix value minus 1 1. Now del F2 equal to del of f of x2, which is equal to what? That is x2, you know, x1 plus del s1, and corresponding values you have to substitute. That is 1 minus 1 comma 1, minus 1 comma 1, plus lambda 1 is what? That is lambda 1 1 of the matrix corresponding to this one is S1. S1 corresponding to this x2 is minus 1 comma 1. So, the net value is what? 1 minus 4 plus 2, and another is minus 1 minus 2 plus 2. So, 1 minus 4 is minus 3, minus 3 plus 1 is minus 1, and corresponding value is minus 1 comma minus 2 plus 2. So, cancel this minus 1, therefore, delta F2 is minus 1 comma 1, this is not equal to 0, further proceed. So, iteration 2 says that S2 equal to minus del F2 equal to 1 comma 1. So, therefore, the rule is f of x2 plus lambda 2 s2, f of x2 is minus 1 comma 1, and lambda 2 into 1 comma 1 is f of minus 1 plus lambda 2 comma 1 comma lambda 2. Therefore, the corresponding value is f of minus 1 plus lambda 2 comma f of 1 plus lambda 2, and substitute this value in equation 1. Therefore, it becomes minus 1 plus lambda by 2 minus 1 minus lambda 2 plus 2 times of 1 plus lambda 2 square minus 2 lambda 2 plus twice of 1 minus 1 plus lambda 2 into 1 plus lambda 2 of 1 plus lambda 2 square plus 2 lambda 2 square. This is plus, so that net value minus 1 comma minus 1 is minus 2, and 2 into 1 is 2, lambda by 2 it becomes plus lambda by 2, minus lambda by 2 get cancelled, and 2 lambda 2 square, and 2 into minus 2 lambda is minus 4 lambda 2 plus twice of minus 1 minus lambda 2 plus lambda 2 plus lambda 2 square plus this term. Further, minus 2 plus 2 get cancelled, 2 lambda 2 square minus 4 lambda 2 square, and minus 2 here, and lambda 2 get cancelled, lambda 2 square here, and then this term. Further simplify, 2 lambda 2 square plus 2 lambda 2 square is 4 2 lambda square plus lambda 2 square is 5 lambda 2 square, and minus 4 2 lambda 2 and 2 lambda 2 is minus 2 lambda 2, and minus 2 plus 1 is minus 1. So, that is the function of f of x2 plus lambda x2. Now, we have a dou f by df by d lambda 2 or dou f by dou lambda 2 equal to 0 implies. So, this is f. So, dou f by dou lambda 2 equal to 10 lambda 2 minus 2. So, that is what they written here, 10 lambda 2 minus 2 equal to 0. So, 10 lambda 2 equal to 2, therefore, lambda 2 equal to 1 by 5. Therefore, x 3 equal to x 2 plus x 2 star into s 2. X 2 is minus 1 1 and x 2 star is that is lambda into this is lambda 2 star equal to 1 by 5 into s 2 is 1 comma 1 and simplify we have minus 1 1 plus 0.2 0.2, further add minus 0.8 by comma 1.2. Therefore, del f 3 equal to 0.2 minus 0.2 which is not equal to 0. Therefore, we have a further proceed to go iteration 3 and S 3 equal to minus del F 3 equal to minus 0.2 0.2 and next we have to find x 4. X 4 is x 3 plus lambda 3 S 3 which is equal to minus 0.8 1.2 plus lambda 3 into minus 0.2 0.2. Then add them minus 0.8 minus 0.2 lambda 3 and 1.2 plus 0.2 lambda 3. Therefore, x 3 plus lambda 3 s 3 equal to do the same process or and substitute in the given function 1. So, 0.8 0.2 lambda 3 minus. So, this is a given function 1, substitute the value of x 3 here, f of x 3 plus lambda s 3 you have to substitute. So, we have what this equation will come and then further simplify, you have minus 2 minus 0.4 lambda 3 plus 2 times of 0.64 plus 0.04 into x lambda 3 square plus 0.32 lambda 3 into twice of minus 0.96 minus 0.16 lambda 3 minus 0.24 lambda 3 minus 0.4 lambda 3 square plus 1.44 plus 0.4 lambda 3 square plus 0.48 lambda 3. So, we have minus 2, 0.4 lambda 3 plus 1.28 and so on up to 0.48 lambda 3 will come and simply add the corresponding terms. We have 0.04 lambda 3 square minus 0.08 lambda 3 minus 1.2. Therefore, dou f by dou lambda 3 equal to 0.08 lambda 3 minus 0.8 which is equal to 0. Therefore, lambda 3 equal to 1. Now, we have a x 4. X 4 is corresponding the value of x 3 plus lambda 3 into corresponding function of S 3. So, minus 0.8 1.2 plus lambda is 1, lambda 3 is 1 into minus 0.2 0.2 and lambda 3 is 1, substitute it, simplify, you have minus 1 1.4. Now, based on this x 4 got it, substitute in the given function delta f 4 equal to minus 0.2 0.2 which is not equal to 0. Now, we go to the iteration 4. So, S 4 equal to minus delta F 4 which is equal to 0.2 0.2. Now, x 5 is x 4 plus lambda 4 into s 4. So, x 4 is minus 1.4 plus lambda 4 is we do not know and s 4 is 0.2 0.2 and substitute it, we have minus 1 plus 0.2 lambda 4, 1.4 plus 0.2 lambda 4. Now, we have f of x 4 plus lambda 4 s 4 and substitute this into the function of the given function equation 1. We have minus 1 plus 0.2 lambda 4 minus 1.4 minus 0.2 lambda 4 plus 2 into minus 1 plus 0.2 lambda 4 whole square into 2 times of minus 1 plus 0.2 lambda 4 into 1.4 plus 0.2 lambda 4, multiply them, plus 1.4 plus 0.2 lambda 4 the whole square. Now simplify. So net value given after addition and subtraction of the terms, we have 0.2 lambda 4 square minus 0.16 lambda 4 minus 1.64. Now you have to find out dou f by dou lambda 4. Here dou f by dou lambda 4 is dou f by dou lambda 4, which is equal to 2 into 0.2, 2 into 0.2 of lambda power 4 lambda power 4 plus 0.16, that is what they given, 0.4 into lambda 4 plus 0.16. From this lambda 4 equal to 0.4, right. Then because it is negative, since it is a negative, therefore lambda 4 equal to 0.4. According to the equation, x5 equal to x4 plus lambda 4 into s. So x4 equal to minus 1, 1.4, lambda 4 equal to 0.4 into 0.2 into 0.2, and simply add them. We have x5 equal to minus 0.92 and 1.48. Therefore, delta Fi equal to 0.28, 0.12, which is not equal to 0. Next iteration phi, S phi equal to minus delta phi, delta Fi equal to minus 0.28 minus 0.12. Therefore, S6 equal to x phi plus lambda phi into S phi. So, x phi equal to minus 0.92, 1.48 plus lambda phi into minus 0.28 minus 0.12, and simply add the corresponding entry. We have x6 equal to minus 0.92 minus 28 lambda phi, 1.48 minus 0.12 lambda phi. Now substitute in the given function. We have f of x phi plus lambda phi into s phi, and given function you substitute, the resultant is minus 0.92 minus 0.28 lambda phi minus 1.48 plus 0.125 lambda phi plus 2 times of 0.8464 plus 0.0784 lambda phi square plus 0.515 lambda phi plus 2 times of minus 1.362 plus 0.1104 lambda phi minus 0.414 lambda phi plus 0.0336 lambda phi square, 2.19 plus 0.014 lambda phi square minus 0.3552 lambda phi. So we have the resultant is minus 2.4 minus 0.16 lambda phi plus 1.693, 0.1568 lambda phi square plus 1.03 lambda phi minus 2.724 plus 0.2208 lambda phi minus 0.8288 lambda phi plus 0.0672 lambda phi square plus 2.9 plus 0.0144 lambda phi square minus 0.3552 lambda phi. So, after simplification, we have 0.238 plus lambda phi square minus 0.0932 lambda phi minus 1.24, and then further simplify and differentiate. So, this is f, and dou f by dou lambda phi equal to 2 times of this you have to do, and then this will come what 1 times, subtract them, we have lambda phi equal to 0.195. So, that S6 equal to minus 0.92 and 1.48 plus lambda phi is 0.195 into minus 0.28 minus 0.12. After adding these two, minus 0.9746, 1.456. Therefore, delta Fx is equal to 0.0136, 0.0372, and is both are approximately equal to 0, and stop the iteration. Now, next problem. Perform 2 iteration of the steepest descent method to minimize the function f of x1 x2 equal to 100 into x2 minus x1 square the whole square plus 1 minus x1 the whole square from the starting point minus 1.2 to 1. Now, we have a del f equal to, simply multiply the equation 1 with respect to x1. Therefore, 100 into 2 is 200 into x2 minus x1 square into x1 square differentiate is minus 2 x1. Second term you differentiate, you have 2 times of 1 minus x1 into x1 differentiate minus x1 differentiate minus 1, first term. Second one is partially with respect to x2. So, first term 2 times of 100 is 200 into x2 minus x1 the whole square into 1, and x2 differentiate is 1, and second term x2 differentiate is 0. Therefore, del f is equal to what, minus 400 into x1 into x2 minus x1 the whole square, sorry, x2 minus x1 square minus 2 into 1 minus x1, second term 200 into x2 minus x1 square. Next is del f1 equal to at the point you have to substitute minus 1.2 and 1. Therefore, the value of del f1 at minus 1.2 to 1 is minus 211.2 minus 4.4 by next term is minus 88, and simplify we have what, minus 215.6, and next term is minus 88, and we have a del f1 is minus of s1 is 215.688. Therefore, x2 equal to x1 plus lambda 1 s1 equal to minus 1.2 to 1 plus lambda 1 into 215.688. So, lambda 1 is the value we do not know, simply add the corresponding entry. We have minus 1.2 plus lambda 1 into 215.6 and 1 plus lambda 1 into 88. So, that f of x1 plus lambda 1 s1 equal to this value x1 substitute here, here x2 in the in 1. So, that this equation will come, expression will come 100 into 1 plus 88 lambda 1 minus 1.2 plus lambda 1 into 215.6 the whole square plus 1 minus of minus 1.2 plus lambda 1 into 215.6 everything whole square. Next we have another problem, f equal to 2x1 square plus x2 square by using the steepest descent method with the starting point 1 comma 2 with the 2 iteration only. So, last problem 1 iteration asked, here 2 iteration they asked. Therefore, iteration 1 f is 2x1 square plus x2 square, del fn equal to 4x1 x2 2x2 mean first equation partially with respect to x1 is 4x1 and equation 1 partially with respect to x2 is 2x2. Therefore, del f1 at 1 comma 2 equal to 4 comma 4. Therefore, S1 equal to minus del F1, therefore, this value become minus 4 minus 4. Now, x2 equal to x1 plus lambda 1 S1. So, x1 is 1 comma 2 plus lambda 1 is minus 4 4. Simply add 1 minus 4 lambda 2 minus 4 lambda 1. Therefore, f of x1 plus lambda 1 S1 equal to, substitute in the 1, 2 times of 1 minus 4 lambda 1 whole square plus 2 minus 4 lambda 1 square. Therefore, twice of 16 lambda 1 square minus 8 lambda 1 plus 4 plus 16 lambda 1 square minus 16 lambda. Further simplify, we have 48 lambda 1 square minus 32 lambda 1 plus 6 will come. Now, partially with respect to lambda 1, it becomes 0 and then this becomes what? 48 lambda 1 square is partially with respect to lambda 1 is 96 lambda 1 and 32 lambda is minus 32 equal to 0. Therefore, 96 lambda 1 equal to 32, therefore, lambda 1 equal to 0.333. Now, we have x2, x2 is what? Initial value x1 1 comma 2 plus lambda 1 is 0.33 into S1 is what? Minus 4 comma 4, that substitute here. So, that it becomes minus 0.332, 0.668 will come. Therefore, substitute in the given function of del f2. So, del f2 is here, del f is given 4x1 and 2x1, del f2 function value substitute you have minus 1.328, 1.336, they are not equal to 0, then go to the next iteration. So, iteration 2 says that x2 equal to minus 0.332, 0.668, therefore, S2 equal to minus del f2 equal to 1.328 minus 1.336. Therefore, x3 equal to x2 plus all lambda 2 x2. So, x2 values minus 0.332, 0.668 plus lambda 2 into 1.328 minus 1.336. So, lambda 2 value do not know, add them you have a minus 0.332 plus 1.328 lambda 2, another value 0.668 minus 1.336 lambda 2. So, x3 got it. Now, f of x2 plus lambda 2 s2, and then corresponding entry you have to take into account. So, this value substitute in equation 1. So, this is x1, this is new x2, substitute in f of x1 comma x2. Therefore, twice of minus 0.332 plus 1.328 lambda 1 the whole square plus 0.668 minus 1.336 lambda 1. So, which is equal to, simplify. So, twice of 0.1102 plus 1.764 lambda 1 square minus 0.8818 lambda 1 plus 0.4462 plus 1.7849 lambda 1 square minus 1.7848 lambda 1. Further simplify, we have a constant 0.2204 and 2 into 1.764 is 3.528 lambda 1 square, and 2 into 0.8818 is 1.7636 lambda 1, and the rest of them keep as it is, and combine this one as well as this one, so that the resultant will be coming here, and lambda 1 add, so that minus 3.548 lambda 1, and the rest of the constant add it. So, we have 0.6666. So, the quadratic in lambda 1 got it. Then differentiate partially with respect to lambda 2. This implies 10.6258 lambda 2 minus 3.548 equals 0, lambda 2 got it. Now, we have x3 equal to x2 plus lambda 2 s2, and lambda 2 we got 0.339, and x2 is minus 0.332 0.668, and s2 is 1.328 minus 1.336. Substitute in the expression, we have a x3 points 0.11, 0.22, and you know del f, where del f3 you have to substitute. So, 4x1 2x2, where x1 value here. So, simplify, we have 0.44 which is not equal to 0, hence the problem.